The level of correlation between two random variables can be a strong indicator for using regression modeling. However, before we do that, we have to be aware whether that correlation comes as association between two variables, or is there actually a causal relationship between them? So what is the difference between these two terms? Well, association between two variables means that we see that when one variable changes, then we observe that the other one changes as well. For example, an increase in weight relates to an increase in artificial sweetener usage, but we don't know which way that relationship goes. So is it so that people who are already overweight start to use more artificial sweeteners because they think it will help them lose weight? Or is it the other way, that they actually first started to use the artificial sweeteners and then they gained the weight? Causation means that we also observe an association, but we make the further statement that one of the variables causes the change in the other one. So we are only able to judge that there is a causal relationship if we design experiments that lead us to make that conclusion. But if we just observe, so we are just given ready data, for instance, the obesity and use of sweeteners, and we don't know what was the arrangement in measuring that data, then it doesn't tell us anything about causality. It only tells us that there exists an association. So another example here, for instance, we know that consumption of peanuts causes wine consumption. This has been studied, and there has also been studied that peanut consumption causes illnesses. So somebody could conclude that consequently there is a relationship between wine consumption and illness, but it's only positive association. We do not know whether there is a causal relationship also in that case in any way. This association is only a consequence of the causal relationships of the two other cases. So that's why we have to be careful, and whenever we have data in our hand, we should be able to make an educated guess at least, or have more information on how the study was designed. Otherwise, it may lead us to conclusions like in here. What's freaking us out here is that we found a correlation between owning cats and being struck by lightning. Of course, nobody would believe that. So in the next further slides, I have some funny examples where there's a very high association between two variables, but most likely there is no causality. For instance, the correlation between divorce rate in Maine and per capita consumption of margarine. Pretty unlikely that they are really having any causal relationship. Next one, number of people who died by becoming tangled in their bed sheets, and the total revenue generated by skiing facilities. Third one, math doctorate awarded in US is strongly correlated with suicides by hanging, strangulation, and suffocation. Following one, US spending on science, space, and technology is also very highly correlated with suicides by hanging, strangulation, and suffocation. Next one, honey-producing bee colonies in US inversely correlates with juvenile arrests for possession of marijuana. I wouldn't bet on any causal relationship in here. And the final one, age of Miss America correlates with murders by steam, hot vapors, and hot objects. So you can see these pairs coupled together and showing association sound very funny, and that's why whenever you have two data sets, you should have some additional information on whether there was any designed experiment to measure these two together, and otherwise always make an educated choice whether modeling is actually reasonable in this case.